Tonight's homework is going to ask us to factor polynomials completely. So we're going to use all our different factoring strategies to come up with the factored form here. So let's take a look at our first problem here, number 7. And on this one, we look at the two terms, and first thing I always look for are common factors. So I look at the 24x and the 40, and I think, what number goes into these numbers? And I want to find the biggest one. I know 2 goes into them. And 4 goes into them, but there's even a bigger number than that. Let's try an 8. See, 8 goes into each of these numbers, and what you're going to end up doing is putting the 8 on the outside of a parenthesis, and then do some division. 24x divided by 8 leaves us with 3x. Do the same thing with the next one. 8 goes into 40 5 times, so plus 5. And that would be our answer right there. Well, the next one, same sort of thing. This time we have some more variables involved in the problem. Well, first thing I look at is the numbers. What number goes into both the 5 and the 10? Well, that's just 5. And then I look at the variables. Well, this one has 3 r's, this one only has 1, so all I can do is pull out 1 r. And so that goes on the outside of the parenthesis, and I do some division. And when I do this, I end up with just r squared minus 2. Well, whenever you have a binomial, look to see if this is a difference of squares, because it is a difference, but the 2 is not a perfect square, so that means it won't factor any further than what we have right here. Now again, you can't take anything more than an r, otherwise you'd have r's on in the denominator. And you can't divide by variables for it to be a polynomial, so that's why we can only have the variables on the top of the fraction. So that's why we could only take out 1 r. Well, looking at the next one here, I look at the numbers, 3 and 1. So no common numbers except for 1, and we don't have to worry about that. So we move on to the x's. Well, this one has 3 x's, this one has 2, so we can take out x squared. And then we look at the y's. Well, this one has 1 y, this one has 2 y's, so let's go ahead and take out 1 y. So we take that x squared y, put that on the outside of a parenthesis, and do some division. See what's left over. So I go ahead and cancel out some y's here, and these 2 x's take away 2 x's on top, so I'm just left with a 3x on top of this fraction. And then on this next one, the x squareds cancel out, and 1y takes out 1y on top, leaving me with a positive y. So that would be our answer. Just x squared y on the outside of a parenthesis, 3x plus y inside the parentheses. Well, this next one has 3 terms. Now, typically we want the leading term, the one with the highest exponents, to be positive. So I'm going to go ahead and take out a negative 3 since I see that 3 goes into each of these terms. That will just switch all the signs there. Now I look at the variables, a squared, a, but this one has no a, so I can't take out an a. So I go to the b. This one has a b, and a b. So I could just take out 1b. So I'm going to put that negative 3b on the outside of a parenthesis and do some division to see what's left. Now you need numbers in each of the places that you're taking out from. So there's 3 terms in the problem. I need 3 terms in the parentheses. So I got to go ahead and do some division here. And so when I do this, the b's cancel out, the 3's cancel out, so I'm just left with a squared. Now let's notice it's positive because the negative sign's canceled. Well, b's cancel out again, and negative 3 goes into 12 negative 4 times, so minus 4a. And then over here, the b's cancel out, left with negative 3 into negative 12 goes 4 times, so positive 4. Notice how the signs switched inside the parentheses. Let's take a look at the next one here. Here we have a 4-term polynomial, and so typically what I like to do with these is I like to go ahead and order them so that I have the highest exponent, then the next highest exponent, then the next, and then the following. So I put it in what's called descending order. So I'm going to go ahead and do that first. 5t to the third, positive 3t squared, and then the minus 45t, and then the minus 27. So I typically like to do that. I just like it in this form. And then I go ahead and put parentheses, because I don't see any common factors between all the numbers. So this one doesn't have a t, and 3 doesn't go into 5. And so we can't use any numbers to factor anything out. So I'm going to go ahead and group the first 2 terms. Treat this as a negative 45 here, and group the last 2 terms. And now take out a common factor between each of these terms. So I see that I see a t squared goes into each of these numbers. So I'm going to pull out that t squared, put that on the outside of a parenthesis, and then see what's left over. So what's left over is a 5t and then a positive 3. And then over here, try to do the same thing. Try to get a 5t plus 3. So I'm going to take out a negative 9. Negative 9 from each of these. So pull out the minus 9. And what's left over? Well, what we have is a 5t plus 3. So notice how the signs all switch when I took out the negative. Well, from there, what we can do is we can take out a common factor. So we're going to take out that 5t plus 3 here. Take out another 5t plus 3. And so that's going to go on the outside of a parenthesis. So I'll write it up here, 5t plus 3. And then whatever's left over, see the 5t plus 3's cancel out. And so I have a t squared minus 9. Now we're not done yet though, because we need to look at those binomials and see if we have any differences of squares. So you see how this is a perfect square, and this is a perfect square, and one minus sign. So that means it factors to a sum and a difference. So bring down that 5t plus 3, and then this factors to a t minus 3 and a t plus 3. And that would be the factored form. So 3 binomials is what we end up getting when we factor that. Let's take a look at the next one here. Here we look for common factors. I see 2 goes into each of these numbers. So always take out the biggest number you can. So pull out that 2 and then do some division. We're left with a y squared minus 3y minus, now 2 goes into 5 2 times. Goes into, with 1 left over, it goes into 16 8 times, so 28. And so we try to factor that again. So you see a trinomial? We'll try factoring as 2 binomials. Y times y makes y squared, and a 7 times 4 makes 28. Well, in order to make a negative 3, we need a minus 7 and a positive 4, and that will end up working out. Well, taking a look at the next one, look for the common factors again. I see that they each have a 3 that goes into each of those numbers, and a variable as well. Let's take out a 3a from each. So I'll put the 3a on the outside, so I'll do it right here. 3a on the outside, and then do some division. I've got a 2a squared, and it's a plus, that makes a 13a, and then it's a positive 15. And so now I need to try to factor further. Again, this is a 2a squared, so I've got a prime number there, so I'm going to start with that. So I'm going to put the 3a on the outside, put the 2a, and then leave a little bit of space for the next term, and the a. Now, since this is a positive 15, that tells me that both signs have to be the same. Since they add to make 13, a positive 13, that means I'm going to put 2 plus signs. Now I need to figure out the numbers that multiply to make 15, but remember the outside terms and the inside terms need to add to make 13. So when I do this, I'm going to try a 5 and a 3 here, and this will end up working out. You see how you get 10a, and here we get 3a, and those add to make the 13a. So it does end up working out. So that would be our factored form there. Well, let's take a look at the next one here. We've got a x squared, or x to the third power, minus 9x. So let's go ahead and take out a common factor of x. We take that and put it on the outside of a parenthesis. Do some division, and always look at a binomial and see if you've got a difference of squares. So notice how x squared is a perfect square and 9 is a perfect square. Well, if those are perfect squares, it's going to factor to a sum and a difference. You just take the square roots of those numbers, x and 3, and then put a minus sign in front of one, plus sign in front of the other. And you see how the outside terms make a 3x, inside terms make a negative 3x. Those cancel out to make 0. That's why I don't see that middle term. Well, looking at the next one here, do the same sort of thing. Look at the common factor. I see a big number of 12 goes into these numbers. And when I take out that common factor, I'm left with 12. And I've got n to the third minus 4. Well, it's not quite a difference of squares because of this n to the third. That's not a perfect square. Not perfect. And so what that means is we can't factor that as 2 binomials. So that's as far as we can take the problem right there. Well, taking a look at the next one, we've got a common factor of 3 in each of these numbers here. So I'll take out a 3, but always look to see if there's any variables in common as well. Well, each has at least 2 c's, so we'll take out 3c squared. You put that on the outside of a parenthesis, so 3c squared goes outside, and then do the division and see what's left over. You got c squared plus 8c plus, then 3 goes into 48 16 times. Well, we can go ahead and try to factor this further. See, we can factor it by drawing 2 binomials, doing c and c. Now, numbers that multiply to make 16 but add to make 8, well, that'd be a positive 4 and a positive 4. And so you could end up writing that as shorthand method of 3c squared times by c plus 4, quantity being squared, since we have 2 binomials that are the same. Well, let's take a look at the next one here. We've got no common factors. I think this might be the first time, so the only thing we could do is draw 2 sets of parentheses and try it out. So I'm going to start with 3d to the third power. And let's see here. If we get a 3d to the third, and we have to have just a 4d, well, let's see here. Does that go in any times? Well, let's try a 2 and a 1 here. I know those numbers multiply to make 2. Well, the only way to make 3d to the third would be to have one as a 3d, maybe squared, and the other is d. And so if I do that, though, you see how you end up with a d squared. So this just does not factor. It's already factored. Already factored. And so it does not factor any further. And so we can't factor it. And we'll just say that right there. There are no factors, and then that's as far as we're going to take the problem. Well, taking a look at this next one, always take out that common factor. So I'll start with the 10, and because each number ends in a 0 there, and I can take out a w squared. So 10w squared is what I'll take out. So that goes outside the parentheses. Let's see what goes inside. And so when I go ahead and do that division, I've got a w to the fourth minus 16. Well, when I go ahead and do this binomial, I see that both are perfect squares. So it's going to factor to w to the second, and then it's going to factor to a w squared minus 4 and a w squared plus 4. Oh my goodness, we've got another set of differences of squares. So you see how we have w squared, that's a perfect square, 4 is a perfect square, and there's one minus sign in between these two. And so that factors one more time. So here's the final answer. It's going to be a 10w squared. And then factoring this, it's going to be a w minus 2 and a w plus 2. And then from there, we've got this w squared plus 4. So there it is. 4 different terms in order to be able to factor that all the way. So there we have it. The answers to some lesson problems. Good luck on tonight's homework.